Right, well, it's just gone 2 o'clock. Welcome along, everybody, this afternoon for this BA Deep Sky section meeting. Very pleased to have the President along this afternoon, at least for a while, and to say hello. So, David, do you want to say a few words briefly first?
Well, thank you very much, Callum, for organising this meeting. I always think the Deep Sky section meetings are one of the highlights of the BAA year. Chance to see all these lovely, colourful pictures of objects that people have been observing and find out about some new objects that we never knew existed and to get inspired to start observing them. Since we're still in a bit of a pandemic, the decision was taken not to hold a real meeting this year, physical meeting. So it is a webinar this year. We're always at the mercy of events, of course, and I'll give you a piece of information that I haven't given to anybody else, in fact, which is rather a sad and serious piece of information. It's about a project that I've initiated to try and get BAA members time on a remote telescope, imaging time on a telescope that's controlled over the internet, and to make that part of the membership benefits. So that's being developed. But unfortunately, the software developers who are developing the platform for accessing this, they're in Ukraine and they're being shelled now. So the development of that has stopped. So we were hoping to get that service working in the next few months, but now everything is in the air. So hopefully things will improve this year. We can only hope. And meantime, there's be lots of things we can observe. And so let's get on with the programme.
Right, thank you very much, David. Yep, our thoughts all go out to the horrible situation in Ukraine, and I'm not sure I know of many amateur astronomers in Ukraine, but there must be quite a few, I imagine. Who must have some reasonably good observing. And there was, of course, the big observatory in Crimea before it was closed down, but I think that was before it was annexed. Anyway, very pleased to welcome everyone along this afternoon. Got two main speakers this afternoon. Owen Brazell, president of the Web Society, and I'm sure is well known to most members of the Deep Sky section, spoken at several of our section meetings in the past. It's going to talk to us about observing groups of galaxies. And also David Davies is going to speak to us this afternoon about imaging the deep sky. Probably David's one of our foremost deep sky imagers in the UK, and still does all his observing from near Cambridge. So it's good to see that we still get some good enough weather to do some great imaging from the UK. So I think without any further ado, we'll pass on to Owen, who's going to kick off this afternoon with his presentation on observing groups of galaxies. Thank you. Owen.
Okay, thanks very much, Callum. Let me see if I can get my screen up and running.
And I'll just add, I'm going to, all the other panelists can turn off their microphones, or else I'll turn them off at this end, and then that'll avoid any accidental interruptions. Thank you.
Okay, so my talk this afternoon is on observing galaxy clusters in the Great Wall, and this is particularly appropriate for this time of year. I will say that I am primarily a visual observer, which is sort of at odds probably now with most of what the BAA Deep Sky section does, but anyway, we'll go through that one. So just to give you an idea, this is a galaxy cluster, though not one of the ones we'll be talking about. This is Virgo, but we'll just briefly go through the kinds of galaxies to set the scene, and then we'll have a look at galaxy clusters and how we classify them, and then some of the tools that might be useful when observing galaxy clusters themselves. So in this image, we see a multitude of different types of galaxies, and effectively we have three main types that we see In clusters, we have elliptical galaxies, which is this large sort of distinct patch in the middle, along with spiral galaxies, which is obviously the other condition there. Spiral galaxies perhaps better known by this rather better face-on image, where we see a nucleus with older stars and bluer stars defining spiral structure. We also see these edge-on, and in this case, a particularly distorted version. This is the Whale and Calf galaxy in Canis Venatici. And because of the fact that galaxies are relatively close together in clusters, we do see interactions between them. And of course, if we look back into the deep past, then we see that most galaxies are interacting as they come together. And these interactions eventually form elliptical galaxies. This image is perhaps one of the more famous ones. This is the antenna galaxies in Corvus. You can see the Hubble image at the top left, and a deep wide field image showing the tails as these two spiral galaxies come together. Eventually, of course, this will be something similar. We'll see it, well, we won't, but if our descendants that are around may see it as Andromeda Galaxy and the Milky Way also come together in about 3.5 to 4 billion years or so. And these take many forms. Sometimes they look like they're interacting. Sometimes you just get optical pairs. But this is a classic interacting galaxy where you've had a number of interactions in the past, and they throw out shells of material which are basically the remains of the galaxy that has been sucked in, shall we say. The other kind of galaxies that we see in clusters, and only in clusters, are what we call lenticular galaxies. And these are galaxies that have the light distribution of a spiral, but they tend to have no gas and dust in them. And this was always thought to be a bit of an issue until we started getting somewhat deeper images. And this particular galaxy here with the long trail is showing that as the galaxy plunges into the cluster, there is a lot of gas running around in the cluster, and this by ram pressure forces out the gas and dust. Of course, it doesn't have any impact on the stars. And this is another similar image showing how this material can be thrown out as the galaxy plunges in. And then we're left with a galaxy that could look a little like this. There's very little in the way of star forming going on. It's the anemic spiral, as we might call it. And these galaxies always form either in clusters, or you see them in the fossil remnants of clusters. And if you see one, then you've got a pretty good idea that there was a galaxy cluster there at some point. Now, originally in the 1920s, Hubble, observing galaxies and trying to classify them from photographic plates, created his famous tuning fork diagram. And that had round elliptical galaxies at the left-hand end, and then various kinds of spirals. Now, he thought that galaxies evolve from left to right, whereas, of course, now we believe that effectively they evolve from right to left through mergers. And you can see that the complexity of the lenticular branch has meant that we've not only got one type, but a number of different types. And we'll see that later on when we start to look at some of these galaxy clusters. So when did we come across galaxy clusters? Well, as it says there, Herschel and to some extent Messier noted that there were a vast number of nebulae in the Virgo and Coma area. Of course, at that point, they didn't know whether they were what they were. But Max Wolf, a German astronomer, is credited with discovering the Coma cluster, which was the first galaxy cluster to be defined as such in the early part of the last century. Though, as it says there, Heineck de Rest also noted lots of nebulae in the area of the Coma cluster. So prior really to 1949, only two galaxy clusters were known. But this was perhaps due to the persistence of Edward Hubble's view that galaxies were uniformly distributed throughout space, and therefore people might see a cluster, but decided that it was either an optical illusion or wasn't really there because of the fact of how Hubble's view overran everything else. But the completion of the Palomar Observatory Sky Survey in 1954 allowed people, in particular, it says there, George Abel, to search these deep plates, and they covered all of the sky as seen from Mount Palomar. And he was able to search out galaxy clusters along with other people who were more interested in groups, like Halton Arp, say. And this meant that by that point in time, galaxy clusters were becoming a feature that had to be explained. This is a rather interesting wide field view of the Virgo cluster. George Abel didn't give this a number because it didn't fit really with any of his criteria. And the Virgo cluster is interesting. Obviously, our local group is part of that. But it is a cluster that's actually still evolving. There are a number of subgroups in that all coming together. M87 at the center of the image here is probably the center of the cluster, but there's another subgroup that's based around M84 and M86 up here. And of course, we have Markarian's chain. The material around it, there is actually intergalactic dust there as well. So these deep images are starting to bring out other features in our own galaxy, not necessarily in that one. So let's look, what is the Great Wall? So in 1978, two astronomers, Thompson and Gregory, showed that there was a link of galaxies or between Abell 1656 in Coma and the Leo cluster Abell 1367 in Leo. Although the number of galaxies they had with redshifts was relatively small, at least they were able to show that there were things in that area. And then in 1982, Margaret Geller and Hukra at the Center for Astrophysics, with many more galaxy redshifts, showed that there was a link between Abell 1367 at one end running through Abell 1656 through to the Hercules supercluster, which is Abell 21, 51, 97, 99, and 47. And this became known as the Great Wall. And this is the image that we have of that. You can see here we have Abell 1367 at one end, the Coma grouping at another, and then the Hercules group, and they formed a bar of galaxies across the sky at equivalent redshifts or distances. Now, as this was expanded to include more and more galaxies, we could see that it was just part of many filaments. This is another much further away filament of galaxies. But the thing to note here, this is the Great Wall again, is that the Coma cluster is elongated in the, well, velocity direction. And the reason for this is not that it actually is, it's because of the movement of galaxies within the cluster have their own peculiar motions, and they would be either side of the mean motion of the cluster, of the group itself. And if we have a look at this, this shows a more detailed view of this elongation, but also shows some of the galaxy groups between Abell 1367 and the Coma cluster. Now, why this is of interest is because after the Virgo cluster, these are the two most, or the two brightest, relatively speaking, clusters of galaxies that you can see on the sky. And if we look here, we can see this in perhaps a better view. So our galaxy is here. We have the Virgo cluster over here, the Virgo supercluster, at about 60 million light years from us. And then we have the Leo, Coma, and the Hercules superclusters at about 350 to 400 million light years away. And then surrounding them, there are various other superclusters and voids. So most of these things appear to be like on the edge of bubbles, really, of a soap film bubble. So that's what the Great Wall is. So we need to have a brief look at galaxy cluster designations. And this is where things get sort of confusing on the historical front. So originally Abell galaxy clusters had a prefix of AGC or AGCS for the Southern Supplement. But for various reasons, they've now changed that, at least certainly in the professional literature, to ACO and ACOS. And this does provide a bit of a challenge. And if you look in magazines like Astronomy Now, despite my best attempts to persuade Mark Armstrong and others that they should call them ACO, they still use AGC. The challenge there, though, if you were ever working with a professional astronomer, there is another AGC catalogue, and that's used for an Arecibo catalogue of galaxies. So the reality is they should be called ACO, but for historical reasons, in a lot of amateur literature, you'll find them still called AGC. Now we can, or people tried, as they always do with things in astronomy, to classify them. So they came up with a simple classification of clusters. So we had a regular compact group, which an example would be the one we're looking at, one of the ones we'll look at later on, which is the Coma cluster, an intermediate and an open irregular. And basically this gives you some idea as to the youth or the dynamic state of the cluster itself. However, this was insufficient, so people came up with a different, a more complex one, and interestingly, they made a Hubble-like tuning fork diagram from that. So we had galaxies with one central cluster dominant, a binary one, and then you've got irregular and linear and what have you types as well. But that also wasn't enough, so people started adding extra classifications to it, just in case you thought you understood what was going on. But it did in some ways give you an idea of what type of cluster you were dealing with. Now, we're not going to go through this. This is a little complicated, well, a little boring actually. But the thing that's for amateurs that's of interest is the richness class, i.e. how many galaxies are likely to be in a cluster. So if you're looking for a richness class 0, you're not going to find many galaxies. And if you're looking for richness class 5, there is only one galaxy cluster that's ever been put into that group, and that of course is something that only Hubble can find. And also obviously the compactness, i.e. how tight the galaxies are packed together, is also going to be something that will be of interest when you're looking through it. So what do we do if we want to look at these, certainly visually? So the main problem is galaxies are a broad band source in general, so a filter isn't going to help much. Somebody had come out with a galaxy contrast enhancement filter, but it had a very mild effect. So basically you're going to need dark skies. And also, if you're going to go into this kind of thing, you're going to need good finder charts. And as I said, you may well be galaxy hopping rather than star hopping. And to give an example of this, many years ago, Stuart Moore and I were on Tenerife using the 24-inch at the Parador, and we were looking at the Virgo cluster, and we got completely lost. We had no idea where we were. We found 3 really nice edge-on galaxies, and it probably took another 5 to 10 years before I figured out where those galaxies were. because just moving a Dobsonian around, you've got don't necessarily have an idea of where you are. It says there a driven telescope will help. This is not necessarily the case. So at Kelling, those of you who've been and had the luck to be looked through Andrew Robertson's 24-inch, when we've been looking at galaxy clusters, will know that it's not necessarily as easy to move through a cluster as you might hope. So it doesn't always go in the directions that you look at. But the thing that does thing is you do need good high contrast objects. Obviously, optics is obviously a lot of the things you'll be looking at are faint on the edge of vision, and also a good range of high quality eyepieces, because again, you're going to be looking at very faint, in some cases, objects. So you need to get the maximum contrast through your system. So just to show you what a galaxy contrast enhancement filter looks like, this is it. The manufacturers refused to publish the transmission curve, which is a bit stupid, because of course somebody bought one and then just put it through a spectrometer and got a transmission curve for it. So as you can see, it doesn't look much different from an ordinary broadband deep sky filter, which is sort of what you'd expect. What you really want, though, is something like this, though probably not with the Milky Way in the way, because you're not going to see many galaxies through that. But you also need some decent charting resources in order to be able to plot the galaxies you're looking at. And you'll find that certainly a lot of US amateurs always swore by something called Megastar 5, something that used to be published by Wilman Bell, but when they shut up shop 2 years ago, the author decided to make it freeware, and he and I did some playing around, and now you can download it from a website in the US. There's also the SkyX, which is used a lot by imagers and people controlling a dome. It's not a program I've had a lot of success with. Guide 9.1 is there if you like your programs to look like DOS, though it is a very powerful program, and the ability to add lots of other catalogs to it is useful. It is also now freeware, and obviously can't do Ciel, which is now version 4, and also freeware if you really want lots of galaxies. I think he now includes something like 5 million galaxies, so that should be sufficient even for imaging and EAA purposes. And you've also got the freeware Aladdin from CDS, and that is spelt right. It's not the same as Arabic things. And there are still some people who use paper atlases, and not that common now. Uranometra 2000 was probably the favored one, and the latest one would be Interstellarum. And as it says there, both of them have atlases. Both the atlases have detailed charts for galaxy clusters. And then there we have things called planning resources, which are probably the things that are updated most. SkyTools 4 is probably one of the better ones. Astroplaner 2.4 is a useful piece of software. It's also one of the, if you have a Mac, it's also one of the few that runs natively on Macs. Iron Telescope 3.3 was written by a German group, was distributed through Cambridge, but it's no longer being developed. But he has made a 3.3.2 version, which is now freeware. You can download from the website and use it for free. And then Deep Sky Planner 8, which is also a very powerful tool and is still being developed. So Astroplaner 2.4 is in beta and has been for a while. It seems to be moving more and more towards minor planets for reasons only he knows. But this is what it looks like. So you can get lists of objects. In this case, it's from the Astronomical League in the US. They have observing clubs, and one of those is for galaxy clusters. And here you can see we've got Abell 1656. You can bring up an image of the cluster in various things, sky survey images, Sloan, and it'll give you a picture of what it's like and shows you when it's up, what the moon's doing at this particular time. and to give you some ideas, and you can make more detailed views of it with data star charts as you wish. Sky Tools is somewhat similar. This is a list of Abell Galaxy clusters, and it again will tell you where they are, what the best time is, and produce some very nice finder charts. So this would be a chart for the Coma cluster from there, for instance, and if you had it in real life, if you hovered over any of the little galaxies that were outlined in blue, it will tell you what information it has on them. And as we can see, it has quite a lot. I know now that many people use phones and what have you. Sky Safari is probably the best of the bunch there. It's on version 6 on Android, but it's moved to 7 on iOS. The version 7 for Android will be due May time frame, I believe. And we have StarMap Pro, DSS Browser, and AstroAid. So these are all programs that allow you to bring up images from the DSS, etc., to have a look at what's going on. To give you an idea, this is of the Abell 1367 cluster with galaxies set to normal, but you can add a extra 3 million galaxies to this if you really haven't got enough there. And if you turn all of those on, then that's the same field, but absolutely loaded with faint galaxies. Now, again, this may be useful if you're doing imaging or EAA type work where you can see down to 19th magnitude, but certainly for most visual users, not so much. There are, however, issues with mobile software you need to be aware of. It says rarely uses checked catalogs. So this is an issue in things like Sky Safari, where it only has 2 galaxy clusters in there, 1656 and 1367, but manages to get galaxies mixed up between the 2 of them because they use an outside source for providing this information. And they're rarely advanced amateurs, though they may say otherwise. However, some people still use books, and all of the galaxy clusters that we'll be talking about this afternoon are in Phil Havington's Cosmic Challenge. There's information in Wolfgang Steinicke's book on the galaxies and how to observe them, which is one of the few decent books in that series. Both Luminal and Skiff and the Web Society Handbook cover these in great detail, which is interesting given the age of both of those publications. And there's not really been another book or any other books since the early 80s which cover this in any kind of detail. If you want to know more about galaxies and how to classify them, these 2 books are useful, though expensive. And of course, we have the Venerable Night Sky Observer's Guide series, which is now back and available. The American Astronomical Association, AAS, bought up the assets of Wilman Bell, and as you're probably also aware, bought Sky and Telescope, and they're now available through the shop at Sky, at least in the US. I believe that First Light Optics in the UK also are carrying them again. But there are a number of other books that cover both the clusters and also images and drawings of some of these areas that we'll be interested in. Now, why have we gone that way? Well, it's because that we're now seeing larger telescopes in operation. This is a picture from Kelling, unusual because there's a blue sky rather than a howling gale and rain. But in the background, you can see Andrew Robertson's 24-inch, and in the foreground, there's a 22-inch Obsession. Actually, in that case, mine. But we're also seeing much larger telescopes abroad. I would say that it's in the UK, it's very difficult to know what's out there in terms of size of telescopes. It has surprised me in the recent past, the number of 20-inch class telescopes I've seen up for sale on UK Astro Buy Sell. And there are quite large telescopes in amateur hands. There's a 30-inch Obsession somewhere in Devon, and we have reason to believe that there are at least 4 25-inch obsessions in the UK, but we never see anything from them. So I don't know what these people do with these telescopes, but that's just the way it goes. This is a 40-inch Dobsonian in Germany. You can see that you have to be quite into heights to use that. And it is one of the larger amateur telescopes in Europe, but probably the largest available now to amateurs. This is a 48-inch Dobsonian in Texas. And as you might imagine, everything's bigger and better there. But you can see the size of the ladder to use it, and it's controlled obviously by a computer and some form of servo cat system, I believe. But I think to use that, you need to use binoculars to observe your star charts. So people do use them, and they obviously look at these clusters with it. So, right, that's the detail stuff. What have we got going here? Well, this is the Great Wall. And as we can see over in the right-hand side, we have Abel 1367. This is a thing from Megastar a long time ago, hence the AGC. And you can see that over here, this is the Coma star cluster, so not to be confused with the Coma galaxy cluster. And then we have the Hercules cluster over here, and it has a bar. This is 2197, 2199, as well as that one. So let's work out from the center. So this is the Coma cluster. You can see in the center of this view, there are 2 large elliptical galaxies. So this is a binary cluster in the Rue Traceri system. As it says there, it's the next brightest cluster after Virgo. It's much larger. Maybe 5,000 galaxies in it. It's difficult to count. It was the first cluster where it was realized that the amount of visible light, or the amount of matter emitting visible light, was insufficient to hold the cluster together. And Zwicky was the person that coined the term dark matter. We needed something. He didn't understand at the time that the mass of gas in the cluster that wasn't associated with galaxies, i.e. intracluster gas, was almost the same as the amount of matter in galaxies, though of course it was still insufficient to hold it together. It's an Abel richness class 2, so it's a reasonably rich cluster, and as it says there, along with the Coma, forms the ACO 13/4, the Coma supercluster. So this is a more detailed image. This is from the Sloan survey. It obviously pointing a bit further in. These are the 2 large galaxies. This is made a little more difficult than it shows here, because there's a bright star not far from these 2, which obviously impacts on the view. But you can see here the vast number of galaxies here. When you're looking at it with any form of telescope, particularly a large one, we sort of coined the name lumpy darkness, because you were able to discern some of the galaxies, but you always were getting hints that there was something else in the field that perhaps you couldn't quite bring up as a galaxy, but there were many more things to follow. Now this, as I said, is just the center of the cluster, so you really do need a chart, and once you start moving further out, there are many more galaxies to see. Now this is perhaps a cheat. This is one of the largest images that, or mosaics, I should say, that the Hubble telescope put together. It was never completed, unfortunately, but it is of the Coma cluster. Now, the intriguing thing here is that almost all the galaxies you're looking at are ellipticals, very few spirals. And we think this is because this is a cluster that is quite old. It's mostly relaxed, so there are some debates about whether there are still subgroups joining the cluster. But this is something we typically find in an older cluster, that most of the galaxies here are ellipticals. Now, in some ways, this makes it easier to see visually, because they tend to have brighter cores, and you can see them, whereas spirals, you might just see the core, but seeing spiral arms is quite difficult at this kind of distance. And again here, this is a much wider field view. And you can see this is the bright star I mentioned, which causes issues with this. So you're going to need a reasonably high power, medium to high power, to keep this fellow out the field and then be able to track down these ones. And you end up moving multiple fields of view and still finding galaxies. So you can see, you know, there's galaxies well out here. So you have to track to follow through. But this gives you an idea. So this is, here we have Abell 1656 on the sky. Here we have 1367. And you can see some of the galaxy groups that are associated in between those two clusters. Now, this is an image that Nick James took just recently of the 1656 cluster from his observatory in Cheltenham. I guess there weren't that many comets out that night. But you can see, even with relatively small equipment, you're getting huge numbers of galaxies here. And you could identify them. Obviously, you can put them into a plate solver and it'll tell you exactly what you're looking at. But this is, you know, equivalent of what you might get visually with a large telescope. If you do want to identify them, this is a really nice chart that a chap called Albert High did, where he took a DSS image and basically labeled all the galaxies in the cluster. Unfortunately, the website that this was taken off has disappeared quite a long time ago, though I suspect he probably wouldn't object if people wanted copies of this image for it to be passed on. So moving on from that, we have the Abell 1367 cluster up in the tail of Leo. And this is the next brightest, next faintest cluster after Abell 1656. And this is a bit more of a tricky cluster. You can see a lot of galaxies in it with what now would be a medium-sized scope, at least by my standards. So my first views of this were from a place called Madog's Wells in Wales, where they had a 15-inch telescope above an old pigsty, which was something we could use. And on a really good night, you could actually pick up a lot of galaxies in this. And just by looking at this picture, you can see that although we have some ellipticals, there are a lot more spirals in this cluster. And because of this, we actually now know that it's a cluster that's really still coming together. There's at least two main subgroups. It's just a fractionally further away than Coma. It's again a richness class 2, but probably on the edge of that in terms of the numbers of galaxies. And unlike Coma, which has got thousands of galaxies, we know perhaps 100, maybe a couple of hundred galaxies in Abell 1367. So this just details where that one is. But you can see here, this is a wide field image, that we've got a group of galaxies up here, another group down here, and this is obviously stars, etc. And you've got quite a few spirals. So this one's going to be a little more tricky. You'll be able to pick up those, and my observations of that would suggest that you can see most of those. And this is again another image of the top half of that cluster, taken again by Nick James from Chelmsford with the same equipment as before. You can see it's a much sparser galaxy cluster. We've got a few ellipticals here. These are the spirals mentioned, and they're far more than they were in the Virgo cluster, and then the rest of it is down here. So this one is an interesting one. Again, there's no bright stars to get in the way, but again, using high power, you can easily pick out most of these galaxies up here, or at least I can. And then when you take a much deeper image using a larger telescope, this is taken using the CFHT on Mauna Kea, you can see here again sort of the bluer spiral galaxies, as well as the colored, yellowish colored ellipticals. And again, Albert High made a nice chart of this based on the DSS on a 1 degree scale to give you an idea. So this is where we were looking at, those are the stars, and these are all the galaxies. There are a number of NGC ones, but then it starts to move down into other catalogues to get, you know, the fainter galaxies. And the last cluster we're really going to look at is the Hercules cluster. Now, this is Abell 2151, and this is quite different to the ones we've seen before, in that most of the galaxies in here are spiral. There's many interacting galaxies, so we know it's a relatively young cluster, still coming together. And again, about there, it's somewhat more galaxies than Leo, but the challenge here is that they're spread over a much wider area. And for those of you who can remember that really interesting shell galaxy and the interacting one, this is him down here. But you can see in this cluster that there are an awful lot of interacting galaxies. Now, the challenge with this one is that because there are so many spirals, the cluster is much fainter and perhaps much more difficult to see than the previous two. So observing this cluster can be a little bit tricky. And again, it's spread over quite a wide area. So you can see here again, you know, all these blue interacting spirals. Albert again did his favorite job here with labeling up all the galaxies in this cluster so you could track them down. I would say that it looks a bit small on the slides here, but the images are fairly high res, so you can, if you print them out or magnify them up, it's easier to read the labeling as we go along. Now, this is an intriguing image. This is something that Ian Genner did using at that time his 16-inch telescope from Kelling. And Ian spends huge amounts of time, sort of many hours, trying to draw these clusters. And this is his drawing of the Abell 2151 taken at Kelling. And using various powers to try and bring out and bring together these galaxies in the cluster. So it shows that, again, with patience and time, you can see quite a lot of galaxies in this cluster, even again with, you know, something you could say is a mid-sized scope. This is more challenging for the imaging side because the field is quite wide, so you need to mosaic it in order to get the galaxies in, or use a wide field telescope, which of course has the disadvantage of a small image size. So where are we looking here? Well, this is perhaps another view of this whole area. So it shows that we've got, where's it gone? Virgo cluster. So we're around in the center here. And you can see here all the other superclusters in the area. The Shapley cluster is the one that we saw in the redshift diagram, which is the next level out. So you've got Coma, Hercules out this way, and then Leo down here. The Leo superclusters are a different group from Abell 1367. That's another set of clusters in the area. So we can see that we have an awful lot of these things out there to see. Most of them, once you get beyond the Great Wall superclusters, are becoming increasingly difficult. The rest of the Hercules supercluster group, so 2199, 2197, are relatively poor in galaxy numbers, and they're almost on top of each other. So when you're using a large telescope, you can track down through them, and then if you're not careful, you just run between the two, and that was one of the problems that we had using Andrew's scope and the drive. We weren't able to track in directions that we really wanted to go, but those two are overlooked, though they are visible in larger telescopes. So these are quite interesting sets of galaxies to go with. 2147 is much fainter and has fewer galaxies, and I must admit it's one of the ones I haven't gone for. I probably ought to. try it out if we ever get decent skies again at Kelling. So I will stop there and ask if anybody has any questions. I will endeavour to answer them. And if you really want that badge, that picture, you can get it from the Web Society and stick it on your car. Thank you.
Thanks very much. If anyone with questions, if you type them in the Q&A, and we'll go through them, and on YouTube, if you can put them in the comments, then I can pick them up there. We do have a question from Davil Dobbs, and he asks, do the voids match the features seen in the Kobe map of the cosmic microwave background?
Sorry, what was that?
Do the voids match the features in the Kobe map of the cosmic microwave background? That might be putting you on the spot there, Owen.
I'm not sure I actually understand the question. So the cosmic microwave background, when it comes through the glass in the clusters, the cosmic microwave photons get scattered out, and you end up with a dark hole, which is how they find very distant galaxy clusters. But I'm not sure quite what Daryl's asking. So what was the question again, Andy?
Do the voids match the features in the Kobe map? I think
no. So the voids match the models that have been done. So using mathematical models to try and model how the universe may have expanded, throwing cold dark matter and stuff in there. We do see these kinds of voids, and just recently there was a paper on trying to match the local-ish area to models, and they did fit reasonably well. So it appears that sort of galaxy clusters form at nodes in the sort of cosmic web, and if you're looking for as far back on the cosmic microwave, it's difficult to match exactly what you're seeing. With Mark Stewart, you've not mentioned the WBL catalogue. So the WBL catalogue is a catalogue of poor galaxy clusters by White and a few others, and they are the Abel clusters are far too rich to fit into that particular one. But people are starting to, or amateurs are starting to look at clusters or groups of galaxies that are in the WBL, that's now available and can be put into programs to see what's there.
No more questions coming in just at the minute. I see there's plenty of comments from people who've enjoyed the talk.
Thank you.
Going back to Daryl's question, I think what it also comes to is the fact that when you look at the cosmic microwave background, you're looking at a much further distance. So whatever patterns you see there will have sort of evolved into clusters and voids at a much greater distance than we're seeing here.
Well, it's worse than that, because the cosmic microwave background is the disturbance at 300,000 years after the Big Bang. So it's when everything decoupled. So you're looking at tiny temperature differences 300,000 years after the Big Bang. And although galaxies seem to form rather quickly after that, which is a little surprising, it's difficult to map what you see today to what you're seeing on the background.
And we've got another one come in. This is from Nick Hewitt. Do any of the large Aperture owners drive their beasts and image the clusters?
No. So, well, the first part of the question is, do they drive? And the answer is yes. So there are several options for putting a drive onto a large Dobsonian. There is StellarCat in the US, though that is, he is retiring from that business, and I don't know what the timescale for that is. But Andrew Robertson's had a StellarCat drive on it, and it was driven from an Argo Navis, though you could have connected the Argo Navis to a PC and drive it like that. But the accuracy that you would need to point to fit things on a chip was not there. There was also a British manufacturer, Keith Venables, was selling something called Scope Dog. So you can see there were some StellarCats and Scope Dogs out there. I'm not sure which chased which. And he also had a Althaus driven system, and he has modified that to use some form of plate solving, so it then drives it much more accurately to the position of whatever he's looking at. But again, no, the answer is people with the large, certainly the large Dobsonians, don't tend to image. You might ask why, but it's just not what you do with a large Dobsonian.
The Andrews telescope is now owned by Dale, of course.
Yes,
Dale
interesting to see how that works out.
Try and use his video camera system on it, though it's not quite there yet. He wrote recently.
Yeah, Dale is trying to run before he can walk with that telescope, I think. He wants to drive it from his warm room. He doesn't want to be climbing up a ladder. So he's going to have to figure out ways of controlling it accurately. Having said that, both the Scope Dog and the Argo Navis have telescope pointing systems in them where you can model the telescope structure. All of that was taken from the work that Pat Wallace did on the AAT. So if the telescope is fixed in terms of its structure every time, then you could model it and make it much more accurate. Having said that, even with mine, where I didn't set it up that cleanly, the object was almost always in this field of view of a medium power eyepiece. So they are reasonably accurate without that. So the big problem in galaxy clusters, though, is there's so many little things there that it can be difficult to identify which galaxy you're looking at, and the Argo Navis, unless you had it point up to arc-second accuracy, probably would miss what it was trying to identify. Any other questions, Andrew?
Nothing coming in at the moment.
Right.
Any on YouTube, Andy?
No, nothing's come through on YouTube.
Okay.
We've got about varies between about 10 and 13 on YouTube watching, though quite often people go back to YouTube later to watch it if they're up to other things this afternoon.
How could they? The football hasn't started yet. There's no rugby.
Well, we've got sunshine here.
Sunshine? No, we haven't got that here, Andrew. Cloudy, grey.
There is the Gloucester game this afternoon, but
it must be new moon, I think. Is it new moon? Yeah.
Yeah, either new or just first crescent, I think. Oh, great. Thanks very much, Owen. That was a really interesting talk. Hope it might inspire a lot of people to pop out and observe some of these galaxy clusters over the coming months. And certainly great targets for visual observing and for imaging as well, EA and longer exposure imaging. And talking of which, I think we'll pass over now to our next speaker. Very pleased to welcome David Davies. David was due to give this talk at our section meeting in 2020, but of course, things conspired to stop us holding that meeting, and I know David's had this sort of in the background because he prepared it for that, but I think he's also updated it since then with some of his more recent stuff. And so, yeah, very welcome, very pleased to welcome David to talk about Fumbling in the Dark. David.
Thank you very much, Callum. Yes, I found it interesting to reflect that I first wrote this talk to give 2 years ago this month in Sheffield, I think it was. So, Fumbling in the Dark, for me, that's a very apt title because, as you will see in a moment, when I started this story, I made a lot of mistakes. I moved very slowly. I tried to do things that nowadays you would say, oh, you just buy one of these, just buy one of those, and get on with it. But as you'll see, let me take you through a personal story, if you like, of an imager from the beginning. So my beginning was in South Wales, and the skies were then very dark. They used to switch the lights off at night. And I particularly remember in the 50s, things like Sputnik 1, Sky at Night began. I used to sit with my dad and listen to Journey into Space on the Light program. So, and in 1961, I do remember the partial eclipse of the sun. We all trooped out of school and watched this happening in the morning. It was quite special. So there were a lot of things going on associated with space and exploration. And two key influences stick in my mind. The first is this, a film made by the National Film Board of Canada in 1960 called Universe. And do look it up. If you've not seen this, do look it up on YouTube. It's quite remarkable. And it tells the story of an astronomer working through the night. And as he is working, they explore our understanding of the universe at that time. And the people, interestingly, who did the special effects for this film then moved on to 2001. The second big influence for me was this book. My dad loved books and he bought loads of them. I can't say he read many, but this particular book, when it was delivered to the house, I grabbed it and devoured it, started to read it, and it's got loads of, it's like a little textbook. It's, I don't know, I suppose you would say first year, sixth sort of level, but it has star maps in it and two particular things in it that I really enjoy. It has what you might call mind models of what the universe is. They're a page describing the relative sizes and distances of things in the universe, and they have 3 or 4 examples of this, and it really brings to mind just how enormous it is. So in my teen years, I then moved on. I joined what was then the South Wales Astronomical Society. I bought a Charles Frank telescope, and this is still my copy of Sidgwick, which I still have, and stood out on the front lawn and explored the planets, the moon, star clusters, even did some solar projection, and really enjoyed myself. And the neighbors stopped laughing. They used to come around and have a look through the telescope with me and enjoy the night sky, which, as you remember, was very dark. Then university arrived. I actually sold the telescope to a friend and moved on. And through the intervening 40-odd years, I kept reading about astronomy, but nothing practical until 2009, when my company then decided to give me a long service award for 40 years service, and part funded this telescope and mount in Stevenage, which is a town not far from where I'm now living. And you might notice I've got a street light here, I've got a street light here, I've got one here, and there's another one over in this corner. So I was well illuminated. And Owen earlier was talking about the effects of light pollution on visual observing, and it was just a disaster. So first experiences out with this telescope, I couldn't see much that I could recognize. So I put a camera on it. I got my Nikon D80 out, strapped it on the side with a T-mount, and I got this image. And I thought, oh, okay, this isn't easy. But through the next year, I acquired a Philips webcam and I started using imaging to look at the planets, for example. And these are some images from 2010. And you might remember Saturn was almost edge on in terms of its rings. I got a very nice image of Mars, and the planets were very well placed. And I was enjoying using the telescope for imaging the planets. But during all this, I had this sort of argument in my mind about what's the best telescope to use. And one day I went out to buy, I actually went out for a bag to keep my bits and pieces in, and I bought a Skywatcher Equinox. This telescope, this photograph was actually taken the following year in 2012. It's sitting on an EQ6, and it does have a guide camera on it. But when I started using it, I couldn't bring myself to, go to the additional expense of laptop guiding and all of that. I was still using the handset. And this was the first image I took with the ED80, and it's unguided with a Nikon DSLR in August 2010. And as Owen has explained, photographing galaxies in light polluted skies is not easy at all. And this was an attempt at M8182 and 3077 over there on the left, using my Nikon D80 sometime during 2010. It really wasn't very good. So I was learning and reading. I didn't belong to a club. I didn't know anybody else who was trying this. I was very much on my own. I spent about 12, 14 months working entirely alone, trying to get the hang of this imaging thing. So 2010 was very much a year of learning. And the key things that stuck in my mind, if you want to do a visual, you need a bigger telescope and you need dark skies. I learned, for example, that Barlow lenses and short eyepieces can give you lots of magnification, but you won't see much more than you would probably see with medium eyepieces. Faint objects need long exposures. And although I was still doing using my mount just to track the sky, they're not good enough for photography. And so I really got good idea why people might start this and give up. And it's at this point I sat down and decided, right, I joined a club. I started guiding, got the laptop sorted out, and set that up in the garden. As you saw me sitting at the table, and there would be nights I would set everything up, take 40 or 45 minutes, and then I'd trip over a cable, and that was the end of that. Or I'd set everything up, or align the mount, and then nudge the mount, start again. So I made lots of mistakes. But during 2011, things started to improve. I was still looking at the moon, still looking at the planets. I was still using visual observation. And then around June 2011, I decided, right, I'm going to start with a refractor. I'm going to do it all properly. I'm going to take lots of exposures, and spent an evening imaging M51. And this was the image for me that changed everything. Because when I showed it to friends of mine at the club, they said, "You've got supernova." And I was so thrilled. I've actually captured a supernova in M51, quite by accident, but with a reasonably presentable image of a galaxy from my then back garden in Stevenage. Big thrill. So I ditched the Nikon camera I was using. One of the reasons for dropping it was that no software would talk to it sensibly. I spent hours trying to get various bits of software to talk to it. I went out and bought a Canon 450D on eBay, and almost immediately replaced the filter in it with one from beta for astrophotography, so I could see deeper into the red end of the spectrum. And here's an image taken with it in 2011 with the camera in its unmodified state. And here's the modified state. So you can get an appreciation of what modifying a DSLR does. So here I am in a typical setup in the garden, DSLR on a 200p Newtonian. I'm using the Finder telescope as the guide telescope, and I've now got myself a little guide camera to go with it. And so I was now well set and very happy learning deep sky imaging by doing it. I have to say my favorite telescope was undoubtedly the ED80, and this is a nice picture of the Andromeda Galaxy captured in September 2011 with a DSLR camera on the ED80 from my back garden. Very pleasing. At about this time, I had a phone call one Saturday morning from a friend of mine saying there's a Skywatcher 120 ED for sale on Astro Buy and Sell. Why don't you go and get it? So I did. drove down to Essex, picked this thing up, brought it home. This was a dream telescope. There's more about this 120 ED later, but this was my dream telescope, the sort of thing you can put yourself nicely to sleep at night thinking about. So I bought it and started using it, and this was a first image of M33 taken with that telescope, which a lot of people thought was pretty good going and very nice. But then at the end of 2011, I retired. And almost the first thing I did, I went to Astrofest in the February and bought this thing, the Skywatcher Quattro, a 10-inch f4 Newtonian. I call it the Beast. And you can see it there sitting on an EQ6. And it is a big telescope and it needs careful handling. But there's the setup, DSLR still. And now I've got a guide telescope instead of the Finder. Good old Teleview sitting on the side. I had aperture fever. But the images were improving. This is M8182 taken with a DSLR during 2012. I'd now retired and settled down, was enjoying myself and achieving what I thought, were quite nice, reasonable images. At least I wasn't shy now to share them with friends, and we could talk about them. Then an inspiration event. We took a trip to the US in early 2012, and I visited the Flagstaff Observatory and learned all about Clyde Tombaugh and his work. And on return, once I could see the M25 star field between the next door house and their trees, which was just a little gap of an hour or so, I took this image one night, 22nd July 2012, with a refractor. And then the following night, I took another. Because there is Pluto. And what you're looking at is the motion of Pluto in 24 hours through the M25 star field. And I shared this image with Astronomy Now, and it was my first published pair of images. That got me going. I must say I always have enjoyed using refractors for imaging. Here's the Dear Lit group and Stefan's quintet down here in the corner. Quite a wide field presentation, but at least now I'm allowing enough time to gather data and getting quite nice images of galaxies, and the spiral arms beginning to resolve themselves in the image. You need a lot of time on the sky to gather the photons. Not just galaxies, but this was a comet in 2012, which I managed to capture and learn how to process and present, and I was quite pleased with that. But then came this image, and I thought, this is the Heart Nebula, and I've been gathering data most of the night. I'd now learned I could leave the telescope out all night long, sweeping across the sky while I'm sleeping. And this is what I got with my DSLR in my light polluted skies. And I'm thinking to myself, I'm at the limit of what I can do here in terms of faint objects. Then everything changed. Two things happened, changed everything. First was we moved. I lived here in Stevenage, as you can see, and this is what sort of light pollution conditions I was working in. And we moved here to Halton, just to the south east of Cambridge, which is where we are still. And it's just gorgeous. It's just a little village of 100 houses. And this is the view south. Sky is just over 4, Bortle. My southern horizon has these trees. I'll mention them again later. And there have been instances when I can actually see the branches of the trees moving along in my guide camera as I'm trying to capture something on the tops of the trees. But just at the end there, you will see, here I am set up, table, tripod, and the ED80 is set up, ready to go. The second thing that happened was I was still working as a consultant examiner for a university, and I was out one night and sitting in a hotel having dinner alone, reading a book, and an email arrived from Dale. I hope he's watching because he might remember this. And he was pointing to an advert in Buy and Sell for an observatory. He said, "This might interest you, Dave, in your new house." And I didn't go for the observatory, but underneath it was an ad for this camera with Astrodon filters, a complete set, and I bought it. I negotiated the sale there and then by email, a phone call, in fact, I think, and then I had dessert. But this was a complete commitment. When you buy a cool camera like this, you're spending a lot of money. This is a complete mental commitment. So there I am, ready to go. And this was the first image from Halton with the Quattro, with the ED80, in fact, taken in the spring of 2014. Absolutely fabulous. So I then began to appreciate what a dark sky can do for you. M97, this is with a Newtonian, just lovely, really enjoying myself now. And then I took this image of the Leo triplet, and I thought I had a problem because I spotted something in the corner. Didn't look right somehow. So I had a look. There it is. Some little dashes, red, green, and blue. And it's, of course, an asteroid. And as I'm exposing the images, the asteroid is moving. And then, suddenly, a supernova. So on the one image, I've got two nice surprises. And this is what I really enjoy about doing what I do. You can get nice surprises as you examine your images. And I do spend a lot of time examining images, reading about what I'm looking at and understanding what there is to see. Then we built an observatory, and I decided the site is really quite exposed and there's no shelter from the wind. If you put the Quattro up there, as I did many times, trying to image N3, and it just got no joy at all. The slightest breeze, and the thing would tremble, and that would be it. I've got smeared stars, and I tried several nights with the Quattro and got quite despondent. I thought, I can't use the Quattro here. It's the slightest breeze just disturbs it. But as part of the budget for the house move was a piece of money to build an observatory. And we quickly decided it has to be a dome. I did ask my beloved about what we might call a big shed, a roll-off roof observatory, but no, no, not suitable, not suitable. So August 2013, we'll bring the guys in and start work on building the observatory. And this is cutting the turf first morning. And looking the other way, this is the pad now poured. This is my little observing station here, and you can see everything's just covered with a cloth, and the mount just sits there permanently with just changing the telescope. So that's where I was getting these images from then. There's some detail of how the floor of the observatory is built, and there it is. This was second-hand for sale in South Cambridge at the time. The gentleman who owned it unfortunately had died, and his widow was selling it. So this was £1,000, and I was very glad to receive it. One of the problems I had was my neighbour's trees. This chap here, I couldn't see Polaris, this chap beside it. So we negotiated and took it away, and I shared the cost. She's a lovely lady next door, a physics teacher. She said, "Oh, your observatory looks lovely, brings a bit of gravitas to the village." An enthusiast. And so I was very pleased. So this was after I'd built the observatory, again, with the ED-AT telescope, one of the first images I secured and was very pleased with. And then I think my love is galaxies. I love galaxies. I see 342, quite difficult galaxy to image because it's in the plane of the Milky Way. There's a lot of intervening dust, although it's quite large. It's quite faint and difficult to tease out during the processing. I'm a fiddler with equipment. I'm not satisfied, especially if something doesn't work right. And I spent a lot of time modifying the Newtonian, the Quattro. I did a lot of work on the secondary mirror support. But one of the things that really bugged me was the halo around stars. Besides the diffraction spikes, we got all these shadows and various spurious spikes. So in 2014-15, I decided to try something. I can hear you now saying, "No, don't do that." I drew up a design for some curved spider vanes, which I bought from the States, but I needed and this was the design for the secondary holder, and it looked like this when I'd finished. And I also took the primary mirror clamps off. I tried to make the light path as clean as possible, but it's very difficult because you've got the bottom end of the focuser sticking in the tube. So the Newtonian, from an astrophotography point of view, is, to my mind, not ideal. But this was my first image. Nice picture of 3184, nice galaxy there. But this, believe it or not, is a star. And as you can see, I've got rid of the diffraction spikes, and what I've now generated is a diffraction halo around the star. And any slight miscalculations or poor assembly of these 60-degree turn vanes will produce shadows and gaps. And you can see there's one there. And there are stars here, and they just don't look right. They just don't look right. Here's Hickson 44. And we're almost at the point of, and this is a galaxy and that's a star, but it's difficult to tell them apart. There's a star. There's a galaxy. There's another galaxy. So in itself, not a very pleasing image. So I went back to the straight spider vanes. And this was one of the first images I took afterwards, NGC 4725. Quite pleased with this, but as you can see, lots of bright stars in the field producing diffraction spikes. There's your 63s, also got some bright stars nearby. And I then took this. This was a very interesting image to take. I spent a lot of time on it, and I was very pleased with it because it led to something of a project. I was now a member of a camera club as well, and working on the committee. But one day we were asked to submit images taken within 5 miles of my home. Taken within 5 miles of my home. So I gave them this. This is the Mullard Observatory, which is just down the road. It's just a couple of miles away. And the image here was taken from my back garden. Of course, it's within 5 miles of my home, but it did do well in competitions. In 2014, summer came and I embarked on a little project to photograph globular clusters. The skies are quite light, so photographing stars, to my mind, is what you can do. So I set off and made a little essay for myself on globular clusters and just enjoyed myself. And you'll notice I used the refractor. This is the 120 in use because I don't like the diffraction spikes off the Newtonian. They say they're thin spider veins, but they are long and they produce, quite significant diffraction spikes. M15, very nice. I'm enjoying this image. And there's your 12. You might, like me, the guiding isn't great on this, I have to say. The red halo around these red stars is beginning to bug me. This is Messier 22. I looked at this again the other day and I thought, wow, there's a really bright blue star here, and these are older stars. The elevation of this puts it just skidding over the treetops at the end of the field south of my garden. But very pleased with that. Then early 2015, it's comet time. Do you remember Lovejoy? This was my image of Lovejoy. Astronomy Now put this in the magazine for me. Thank you very much. Really enjoyed that. Very nice. And then in 2015, I set off on my Messier 27 Dumbbell Nebula project. I knew that M27 had an outer region which was very faint. So I tried to work out how best to capture this. So what I did, I started with an image which was from the refractor. Here it is. It's a straightforward RGB image. It's quite pleasant. It's very nice. QSI camera, Astrodon filters. You can believe the colors. The teal oxygen 3 is about the right color because the Astrodon filters make sure that the oxygen 3 is evenly divided between blue and green. Both filters capture that wavelength. And then I captured narrowband data with the Newtonian, and I ended up with this. So this is a combination of RGB and narrowband data in hydrogen, oxygen, sulfur. I think this is the Hawaii telescope palette. So it kind of looks like an RGB image, but it is actually narrowband. But I have got RGB data for the stars. So I really enjoyed this, and BAA honored me by putting this on the front cover of the journal, which I was very proud of. And the Hubble palette version, same data, just different processing. This won me second prize in an astronomy show, which is now the Practical Astronomy Show, but in 2015. So it was very pleasing. I have to say, I've mentioned how much I was in love with the idea of the 120 ED refractor before I bought it, and how pleased I was when I managed to get it. But my first experiences with it were rather disappointing. I, in truth, wasn't allowing enough time. I wasn't gathering enough data. This, by the way, is the crab, of course. a bit over processed, but it's extraordinarily noisy because there just isn't enough data there. You need to spend more time. And I then did an experiment. I love Messier 92. Everybody looking at Hercules thinks of M13, but 92 visually is just lovely. I think it's just a lovely cluster. So I took an image of M92, but you'll see I offset it deliberately to the top left corner. And the reason is there's a lot of very interesting things going on here. And I wanted to see what my refractor would make of it. And this was the result. Owen showed us some lovely sort of negative images, but I spent a good few hours looking at this image and marking up and identifying the galaxies I could see and their magnitudes. So I was beginning to get a feel for how deep I could go from where I am now in my garden. Mag 18 there, Mag 19, 19.2. They're just tiny little fuzzy spots. But it really demonstrated to me the power of capturing a lot of light from the sky, spending several hours, capturing this data. And this is with a mono camera, red, green, blue, and luminance, and putting it all together. It's a lot of work, but it's so pleasing. I was really, really pleased with this. But looking at the refractor overall, I really wasn't very happy with these halos. I think the Equinox 120 was a rather strange telescope in that the two lenses that it has correct green and blue, and it lets the red go. And the red image is too big. And as you can see here, it means that you get a red halo around the stars. Most other refractors, I think, tend to fix the green and red and let the blue go, which is a rather fainter color that we're less sensitive to. So you tend to end up with a blue halo with these ED telescopes, which is, potentially a bit more acceptable. So the 120 had to go. And I then went out and bought a APM 107 Apo, again at Astrofest. Again, it was the first thing I did when I went through the door. And to give you an impression of what happens when you make that sort of move, an ED 120, what was it? Several hundreds of pounds. I think I paid £1,000 for it. APM 107 is £2,000. But I'll remind you of this image of M33 that I took when I started out. That's what the APM 107 does with the same target. I think this is just lovely. I so enjoy this image, and I spend a lot of time exploring it and zooming in and examining the trails of stars in the spiral arms, and against this very much fainter gas and dust in the background. Very enjoyable image for me. And the key thing was my stars were white. White stars were white with no halo. That's what you get when you spend a bit of money on a proper Apo. And again, this is the Iris Nebula, and I wanted to capture the dark voids and the gas and dust in this area of the sky. And this was another image that appeared on the BAA journal. So very pleasing. Then I did a silly thing. I remember Callum saying to me, "I'm not sure you've done the right move there, Dave." I sold a Newtonian and I bought a Ritchie Chrétien telescope, and this was the first image from it, which is, to many might be quite acceptable, but the star halo was not very nice. Something was wrong with this, and I ended up taking it to bits, absolutely to pieces. There was a broken O-ring that was securing the mirror. I looked at the mirror itself, and it's got this chamfered edge. This, you know, you learn a lot about how these things are made when you take them apart. And then 3 times around the edge of this dark shadow, which is the clamp that held the mirror when they silvered it. This is the unsilvered bit. So this is a nice light scattering edge. And then you get these. So I painted it. I think it was Warhammer Chaos Black, if you want to know. There you go. I painted the edge. I also did a lot of, I repaired the mirror mount, replaced the O-ring. I removed the extension to the shade tube, which a lot of people said was necessary because you could actually see the sensor from the front. But it actually vignetted the image. And it was Ez Reed that proved that to me. I removed the baffles and replaced it with some decent flocking, recollimated it and did the old raunchy test and all that sort of stuff. And it's now working at its correct focal length, which is a bit of a surprise. It's 40 millimeters longer than advertised. But it does produce nice images. An RC scope in properly adjusted will do a good job and gives lovely colors. I love the colors of the stars. This is an image which I suspect is not quite in focus, but the tiny stars really make me very happy. And that's what I'm enjoying. Now we come to the time when I was going to give this talk 2 years ago, lockdown 2020. Do you remember lockdown 2020? We had some of the clearest transparent skies in as long as I can remember. Airplane trails disappeared. And I thought, I'm going to see what my RC scope can, how small can I go? How faint can I go in galaxies? Galaxies are a bit of a theme of this session, isn't it? So I spent a very happy spring during lockdown photographing galaxies. So here's the I think it's called the integral sign, and you just see some of the gas and dust there being pulled out by its neighbor here, which is causing this odd shape. Again, colors of stars, lovely. This is NGC 2841. Really enjoyed this. We've got some really faint, smaller galaxies down here. Mag 1516, I think we're probably looking. This one, I think, is Mag 16. Very pleased, and some lovely detail coming up in the dust lanes. And this galaxy, I think it's this galaxy, is when I first processed it, it looks a bit odd. It's got a lot of gas and dust hiding this side. So you can't see much in the way of detail, as opposed to this side, which is, I think, the side closer to us. 3718, lovely. This is an ARP, of course, 214, and this is Hickson 56, ARP 322 at the top. And very enjoyable. Now, one of the things I was doing now at this time, we were all in lockdown, people were a bit anxious and stuck at home. I set up a almost weekly newsletter from my desk here to the rest of the village, and I would share with them the images I was getting in the sky and tell the story about who discovered or what's going on or how far away it is. And that's an aspect of imaging that really thrills me, and that you are looking at something, 60, 100 million light years those photons have taken to reach my telescope, and I've caught them on my sensor. And then I would, in my little newsletter out to them, my email out to them, I would say, well, at that time, the dinosaurs were roaming the earth, and the world was a very different place what it is now. And that's one of the thrills of imaging and in astronomy, is that you're looking back in time, and there it is, and you can appreciate it, enjoy it in front of you. 3432, another ARP 206, with its very faint companion here just coming up. This is an 8-inch telescope doing this. So this is what you can achieve from a dark sight with time. And one of my favorites, I have to say, Messier 108, I particularly enjoy here the foreground double star, Mag 15, tiny, 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 but well resolved and presented nicely. M98 and a little group here, Abel 1499. Of course, times are changing and there are hazards and things that now pollute our skies. And here's my Messier 91. One of the frames caught these 3 Starlink satellites trundling across. This one is truncated because that's where the exposure ended. And I've got a version of this with that frame missing and a version with it in, but it does kind of bring it home to you what these things look like on a long exposure photograph. So early last year, disaster struck. My mount no longer tracks correctly, and this is a sub taken then. And you can see how the stars are moving, skipping. At first, I didn't want to believe I had a problem, but I had to admit to myself I had a problem. The mount is no longer tracking. And so we start to have a look. And those with, it's an EQ8 now, and those might recognize this is the RA axis worm is in this block. And this is the RA axis main gear here. And the problem is these 3 screws, there should be 4. There are 3 and they are at different lengths. Somebody's been in here before me. Most of my stuff is second hand. And this is one. I bought this second hand. And I don't know how many previous owners it had had. And there was considerable damage caused both to the worm. There are chips out of it and scuffs on the surface. And this is the damage to the main gear. So lockdown 21 was spent rebuilding, completely dismantled it on the kitchen worktop and rebuilt it there. And I'm indebted to Tony Owens of Shubimi Engineering in Ireland, who's a moderator on the EQ8 group, who helped me. He repaired my broken bits. He supplied me with other parts. And I was able to rebuild the mount. And it is absolutely superb now. I mean, I don't think I need a Paramount or a Mizu or something like that. I can achieve, as you can see here, 0.27 arc seconds RMS, 0.25 seconds RMS tracking error. Just to put this in context, the distance from here to here is 2 arc seconds. This is plus minus 2. So this is half the diameter of a star in our seeing conditions. And I'm tracking, my 3 sigma error is probably around 1 arc second, which is sort of a third of the diameter of a star. And just to put it in context, if you go at 3 miles, you hold up a pound coin, and that subtends an arc second. That's the challenge you've got in guiding to do deep sky properly. So to close, where we are today, there it is, it's still there. I'm thinking I need to motorize the observatory somehow. I think the only way I'm going to achieve that is to actually replace it with a modern housing. I've now got an all sky camera, which is proving invaluable in terms of monitoring how the sky is as I sit here and do my imaging from my desk in the house. I used to have a very manual process. I used to do everything manually. These are the software I used, Brazell, which has been mentioned, but I did manual plate solving. I was fortunate enough to find on cloudy nights, a gentleman by the name of Kevin Brazell, who's developed an application from Scope Focus, which he happily shares with people. You can find it on the web. And that did my focusing. I used nebulosity for data capture, PH2, and all the rest of it. But I used to do meridian flips manually. And if I had multiple sessions to capture data, I'd do the reframing manually. So I used to spend a lot of time in the observatory just setting things up. And because of that, of course, I used to keep a lot of notes. I still keep notes, but I'm on my 3rd or 4th book of notes, and everything is noted. Everything that I've ever exposed is still on disk somewhere. Here are my telescopes. Still just the 2, and I'm very happy with them. My most recent acquisition is this camera, a cooled all-color camera, which I now use for EAA and some outreach work, which I enjoy doing with the Institute of Astronomy at Cambridge University as a member of the Cambridge Astronomy Association. We are a group of observers, there's 4 of us, who get targets set to us for Wednesday evening observing online. And an astronomer in Cambridge then talks about the object that we're looking at. And I've found this to be an ideal camera with sharp cap for EAA. So if anybody wants to get in that, it's a good place to start. The software is here. I think all of that is free. It's astonishing. Nina, if you might have heard of Nina and thought about it, it's an excellent, excellent application, and it's free of charge. I've actually given them money because I'm so pleased with it. But it does all of these things for you. It will control the dome as well once I sort that out. And I've now got a Pegasus power box, so I can switch things on and off, reboot cameras, etc., all remotely. All the images are downloaded to my local area network, and I can control it from this PC or from an iPad and monitor what's going on. But this automation gives me time. That's the thing that we haven't got in bucket loads, is time. We're all getting older. The weather is horrible most of the time. And when a gap appears in the cloud, the all-sky camera tells me it's clear. And this software allows me to capture things very quickly. This is my process workflow. You can catch up with the detail of that looking back, but those PixInsight users will recognize some of these things I do here. One of the things that might surprise you is that the one-shot color images from that camera, I actually split to RGB and then realign them, and it cures some of the little fringes you see around stars due to the Bayer matrix. I don't do any sharpening as such. I do a bit of contrast enhancement. And just to close, I'll just share with you a couple of my most recent images. I don't do a lot of what you might call big sky, pretty pictures, but I did enjoy the North American nebula. I was surprised to discover it's actually lilac in color, not red. I use photometric color calibration fixed on the stars, and that gives me confidence that whatever we're looking at in the background is actually correct. You remember my picture of the Heart Nebula from the beginning? This is its neighbor, the Soul, in RGB. And here's the narrowband version, which I really enjoy. And to finish, a couple of shots from that one-shot color camera. It's taken me a while to get a workflow that I'm happy with in terms of color accuracy with that, because the raw images have a huge color cast on them. But here's M81, which is that galaxy I was really trying again and again and again to photograph in my garden back in Stevenage all that time ago. And this is from last week. This is a rather noisy image of M87, which Owen mentioned. And if you don't stretch it quite as much as that, you will see in the center, there's the jet from the black hole at the center. I was quite chuffed to get that. So that's it. Thank you very much.
Well, thanks very much, David. That was an excellent talk. I'm sure there'll be a few questions arising. I think I'd just like to say that the BA doesn't endorse you taking your Ritchie-Chrétien telescope apart to maintain it yourself, unless you know what you're doing.
I would echo that. It's not something you should do lightly.
And likewise, maybe changing the filter on your Canon DSLRs is
Yes.
it used to be quite a common thing, but I'm not sure people do it quite so much these days. So maybe there's less.
They go straight to
straight to color cameras now, isn't it?
Cool cameras are now so much of a commodity. They are, most reasonably priced, and you can get them. When I started, of course, China was just getting going, as it were, in producing telescopes. But now many things for deep sky photography are commodity items. You just go and First Light Optics or your favorite vendor and go and buy some.
I'd also like to thank David because he's helped me with my advice on my dome, because we both got the same sky dome. So I've often had questions, and David's been very pleased to answer for me on suggestions to make it work better.
I think I'm going to have to go Pulsar, but it's a lot of money.
Yeah, it's not the lightest of domes to motorize. I think, yeah.
Well, fascinating to hear your journey, and also congratulations on actually getting to the bottom of those problems by persisting and taking bits apart.
Yes, indeed. When I said I make mistakes, that's how I've learned. Make lots of mistakes. And I curse myself sometimes and think. I give a talk on how to do imaging rather than the story of my imaging. And my concluding slide is you must be very patient. You must have a passion to do this, otherwise you're just not going to succeed. You have to be a problem solver. You have to be very persistent. Especially like me, you're working with secondhand stuff and budget equipment, It's a project.
What wise words on patience and just keep at it.
Yeah.
We've got a couple of questions which have come in on Zoom. So we have Paul Whitmarsh. He says he loves the color balance and the level of saturation. How do you decide how far to go with color processing?
That's a very good question. I made a study of star colors. It was one of my projects, and there are universities you can go to who actually will give you, for example, the formulae for various BV designations of stars. And I've actually made a patch panel that shows me what the star colors are. And I can compare those with what I've got. But the photometric color processing now does that for me. When it comes to things like saturation and fiddling with the colors, when I started, I used to, say, I'd like it a bit more blue, and I'd like it a bit more red, and I'd like more of this and more of that. But as I've developed, I've decided, to me, it doesn't look right. My key driver is it's got to look realistic. And often I will prepare an image and I'll say I've finished it, and I'll leave it on the screen and go away. And several hours later, I'll come back. and turn down the saturation. I look at images online, and I have to say most of them I'm dismayed, because the ones that get the oohs and ahs and the wows are the brilliant blues, the brilliant reds. I must say the one-shot color camera is a good teacher, because my first images of that convinced me very quickly most of the universe is beige. Beige and grey. It's these brilliant colors. Unless you're sensitive to the ionized gases, they're not. The colors are very subtle. So you take your time, and turn it down.
Good advice. And there's a question from Dave Shepherd, which is, are there any planning permission issues about building a dome?
I didn't find any. I did read up on this, and there were various things about permanent electrical connections as an outbuilding, etc. I did seek permission, if you like, from my neighbours. We're fortunate here in that we're not overlooked. It's open at the back, and my neighbours on both sides tolerate what I do. I think if I rebuilt the observatory now, I'd make a green one. And that would make it a bit less prominent. But the whole observatory, if you like, plugs into a 3-pin plug on the outside of the house, just at the back of the garage. There's nothing fancy about it. And all my Ethernet connection, etc., goes up and down that wire using power plug technology. So if I didn't seek permission from the local authority, I sought permission from my neighbours. But it's not something I'm expert on from my point of view. I have to say, you have to read up on it. But I think it's okay. And my insurers were okay with it as well. They just regard it as an outbuilding. And the things inside it are insured up to a level.
Yeah, that's good. Yeah,
I had a bit of a discussion with because I've got the same dome as David has, and I think I had a discussion with the planning department, and they decided it was a flat roof. So flat roof building regulations are, outbuildings applied. So it had to be less than 3 meters high or something like that, which is the maximum for in our area, or 2.5 meters high or something, which was the maximum for a flat roofed.
It is bigger than that,
but it's not as it wouldn't be classified as a pent roof or as a V roof.
I think I'm lucky here, because there's very much an astronomy feel about the village, because the Mallard Observatory is just across the road, and people are proud to be here and have that on their doorstep, as it were.
Yeah.
The other thing is, of course, if you do this, I think it does help to engage with the community and, share what you do, as I did during lockdown, and shared my images with commentaries, and that was very popular.
We have a question from Daryl Dobbs, which is, have you got, or are you considering converting your mount to belt drive, which seems to be popular?
It is belt drive. It's an EQ8 now. But when I had the EQ6, yes, I did convert it to belt drive too. I bought the kit and did that work. But the EQ8 is belt drive in both axes, and I recommend the EQ8, but they're now quite expensive, about £3,000 for a new one. They are 25 kilos. They're quite heavy. But it will carry 50 kilograms, and one properly adjusted will work very well.
We're getting a lot of positive comments as well in the chat from people who enjoyed your talk.
Yeah.
So this is what old guys can do, and gals, when they retire, see.
Well, that was great. Thanks very much, David. That's very much appreciated. I'm sure if anyone's got any questions afterwards, just email them in, or you've got David's email address already, then or pass them by me, and I'll pass them on, or I'm sure many of you might have David's email address already. Anyway, and I'm sure he'll be quite happy to answer any questions anyone's got. So thanks again, David. That's very much appreciated, and yeah, really great to see your journey there. Right, so final section. If I can find the right thing to share. It's just a quick update on the section. Actually, I'm just going to do a quick update on the rugby if Nick Hewitt's around. No, we won't go for a quick update on the rugby since Gloucester are losing to Northampton at the moment. But where's my slides? Here we are. Right. Yeah, so this is just a quick review of the year. Just a few slides of highlights from the last 12 months. So just a quick update on section personnel. So it's more or less the same as, in fact, it's exactly the same as last year. Thanks to all of those who have helped out with the section: Jonathan, Ron, John, Nick, Guy, and Paul. Section members have gone up to around about 210. I think somebody signed up yesterday, so maybe it's 211, which is about 11 up from last year. That's basically members who subscribe to the email list, and that's where I maintain the membership list now. It's great to see the numbers increasing year by year, really. Did manage to get out a section newsletter last year, Deep Sky 37. I'm possibly going to do these every 6 months if we can get enough material for them. I think it's useful to get things like the variables, nebulae reports and double star reports out more frequently. So I'll be getting in touch with Nick and John, and hopefully we'll get another issue out before this or after the summer, and during the summer sort of recess when observing is a little bit less possible. So these are all as PDFs, and members can download them directly from the BA website. Continue contributing to the journal. So in the Observers Forum, many thanks goes to Owen and Stuart Moore, who help with the Deep Sky object in each or topic in each of the Observers Forums. Try to get one of those in the journal every issue, and also this in the last journal, it was nice to see the paper from Grant Privet and Terry Evans on the R Corona Borealis, R Corona Australis variable nebula. So I've had a couple of papers over the past few years, so that's good to see. Website's been updated slightly since last year. It is, of course, the new look website, but the section pages have been updated through the observing programs, really, mainly around the globular clusters. So Paul Leland wrote a large amount of material on the globular clusters, galactic globular clusters. So many thanks to Paul for doing all of that. And we now have a full list of galactic globular clusters on the site. So if you are interested in having a go through that challenge, a big challenge, but there's a lot of them, and it would be interesting to see how many people can grab. Also updated the variable nebulous program site, so there's individual pages for each of the main variable nebula that we have, and all the publications are in the publications area. Not sure if this, when we did this, it might have been previous year, but Owen very kindly scanned all the original Deep Sky diaries and other Deep Sky publications. So we've got all of the things that the Deep Sky section's produced since it started in 1982 up on the website now. Members' albums still continue to be popular, and it was great to see the variety of images that Deep Sky images that people are putting up there. This is just a nice image from Manolo Rodriguez in Spain, who's been doing some lovely imaging from his observatory in Spain. And just to cover off what's been happening in the Deep Sky, this is just a very brief view, really. This says using the members' album image library software, we can create this map of the sky, showing where all the observations have been taken and the areas covered. So we can see that a lot of the observations are taken across here in Auriga and around Orion, of course, and a lot across in Cygnus, of course, to be expected, but all sorts all over the place, really. So quite a wide coverage across the sky. And on the bottom here is the when the observations were taken in 2021, 22, Deep Sky objects, that is. So we've got these peaks, I guess, mostly around the better periods of the year for observing. So early May last year was a good time for observing. Late September seemed to be quite good, and then lots around in December, in November through December. And slightly picked up middle of February, though the weather for me here in Gloucestershire has been fairly poor throughout. I did mention the variable nebulae before. It's one of the programs which has been quite successful over the past year, and had some new observers starting out, or who have been doing it and sending in more observations. Hind's variable nebula is first up here, and Richard Sargent has been doing some nice imaging of it. Hope this animation works for everyone. This is just 2 frames taken between January 21 and October 21, and showing considerable brightening of Hind's Nebula over that period. So definitely well worth following up on observations of the variable nebula and see what's happening. Hubble's variable nebula, been nice to see that being imaged. Nick Hewitt took a picture there with his from his home observatory. I'm not sure he's operational at the moment, but that was back in March, and then this year's a picture by Martin Cook. Diobadagian's nebula has always been interesting. Seems to be fairly faint at the moment. This is the latest, a recent picture from Mike Harlow. You can see the nebula is this line here. Last year, Mike did a little video of it, and let's hope this plays okay. It's March 2020 to August 21, and you can see Mike's images through the period and the development of the nebula. Sometimes it just disappeared almost completely for a while, and then reappeared, and have this fairly long linear structure and some brightening at times. So yeah, again, fascinating object to follow. Would be great to get some more observations of it. McNeil's Nebula, I go with that last year with an eye telescope in December, and sadly still nothing seems to be apparent where it should be. So a bit of a watching brief on that one. Maybe it will be honing out of view in the next couple of months. So maybe come the autumn, we might be able to see whether it's decided to make a reappearance or not. But at the moment, it all seems pretty much invisible. 4 further variable nebulas have been observed. Again, they're not really seem to be doing too much at the moment. Holmes Nebula, Borisov, Corona Australis, and the V347 Auriga nebula has been interesting. That's been another Richard Sargent's targets, and he's been doing well. But yeah, we've had a fair number of people who've been making observations of variable nebula through this year. I'd like to thank all of those, and sorry if I've missed anyone out that I didn't manage to spot. And I was just going to finish off with a few more images of note. It's just a random selection, really, of things that have either come to my inbox or I've spotted on the members' galleries. This was a nice image of North American nebula. We saw David's one a little bit earlier, and this is a wider field one by Paul Whitmarsh from Uckfield, so it's probably not the best disguise there, but it's a really nice image using White Cat 51 refractor, I think. And I was enjoying Paul's images with that so much that I went out and bought one of the red cats myself, but I haven't really got much to show for it yet. Martina McGovern has been posting some excellent pictures. I think David posted, had one of this nebula in Galaxy in his presentation as well, NGC 660 in Pisces. So it's another splendid image, and Martina's well worth having a look at of her images in the members' albums. I mentioned Manolo Rodriguez in Spain before, and he sent in this lovely image of the coat hanger. It's really nice to see the difference in star colours between the different stars in the coat hanger. Peter Goodhue gave a talk last year at the section meeting, of course, and is continuing to follow up on these potential planetary nebula discoveries, and this is a really nice image of one of those targets using his remote telescope in Spain. And Ian Cartwright in Ayrshire in West Scotland continues using his, doing, I guess, similar to what David's been doing, using a Newtonian reflector with a DSLR, though Ian uses Nikon cameras fairly exclusively now, and this lovely image of Messier 33. Dennis Buzinski, although he's more of a comet observer maybe, but he always sends in some really interesting deep sky images as well. IC514, the Cocoon 46, the Cocoon Nebula here, and happens to have a near-Earth object transiting it at the same time. But this is from the fairly far north in Scotland, north of Inverness, so Dennis gets a huge number of good nights of skies up there, so it's great to see that you can get good observing all around the country. Though I suspect he gets better dark skies than most of us in the south. It's another of our European observers from Italy, Mattia Piccoli. And this is ARC 273 and Andromeda, a nice interacting, nice cluster of galaxies here. And again, it's worth seeking out Mattia's pictures on the members forum. I think he's producing some really interesting targets. But many thanks to everyone who submitted observations through the whole year. It's always appreciated, and I try and keep track of everything that gets posted up on the members' albums. It gets a bit difficult sometimes because there's so much happening. It's difficult just to keep track of it all. Looking forward to the following year. I think I said this last year, but we're hoping to have another review of the programs variable nebula is well established, globular cluster programs in place. The other programs I'd like to revisit, probably quite like to get the local groups, Galaxies, the program running a bit more. New program ideas, always appreciated. And I'm also looking at ways into the new website that we can feed the members' images into the program pages. So those can all be like a one-stop shop where you want to look for images that have been posted already. Also, the possibility to upload the section archives onto the BA image libraries is an ongoing project which got started, but it's kind of paused at the moment. But if you have any ideas or thoughts about what you want from the section, please let me know. Anyone that wants to help with the section, I'll always appreciate any help that anyone can offer. And that's just the end of the chat. If anyone's got any comments or anything, and wants to put them in the chat or in the Q&A, then I'll try and answer any thoughts that anyone has. Or if anyone's got any other questions for David or Owen, then now's the time for it. Stop sharing.
So no questions at this time on.
I thought I had a point in my slides actually, but I don't think I included it. But yes, I'm hoping that in 2023 we'll be able to all get together in person for a proper section meeting. I'm not really sure when or where. It's kind of difficult to work out what you're going to be doing next week, let alone in a year's time. Hopefully, we'll have it hopefully we'll have it somewhere. It won't be on Zoom. Any ideas of anyone that would like to host it in any of the easily accessible locations, please let me know. I'm always happy to take it around the country. Whether we can, well, I'm sure we told it down in Cheltenham if we wanted, or up at Bedford maybe, or Cambridge, or all parts north or south. Anyone that's got any ideas of venues that might actually be prepared to hold it, that would be great.
So just for interest, Callum, we're hoping to hold a web meeting physical meeting in Cambridge on the 18th of June at the IOA again. So
all right, okay.
We have permission from them to do it. So we're working on the program with Stuart at the moment. So that should be our first attempt in 2.5 years or something. And we may only be able to have a limited number of people, but we'll see how it goes. But that's our first run at it.
That would be excellent. It would be good for get the Deep Sky Observers all together again.
Well, it's the 200th anniversary of the death of William Herschel this year, so I'm guessing we should have something about that.
Can I just say thank you to Callum and Andrew for running the session, and thank you to everyone who made such nice comments about my talk. Hope to, as Callum said, get together in person.
Thanks very much.
The IOA isn't open at the moment, I believe, but hopefully it won't be long now.
My local society is planning another first together meeting in April, so it'll be interesting to see how that gets on. People are feeling a bit more relaxed about things now. That maybe that's just the quiet before the next storm. fingers crossed. It's getting better.
Well, on the BAA front, we've got the next Wednesday webinar on the 16th of March, which is on silvering, or the history of silvering telescope mirrors. Then
yes, that's Howard Spanich, who's Northwest American astronomer, gave a talk to us last year as well. He's actually one of the people that uses the spray silvering technique for actually spraying silver onto your telescope mirror. And I did follow this for a little while because I thought about having a go at it for my old big, when I had the 20-inch telescope that Mark's now got, as a way of recoating it. But found that you can actually import the kits that they have in the States because of the noxious chemicals in them. So unless a UK manufacturer or supplier wants to sort of make the kits in the UK in some way with UK chemicals, I'm not sure whether that's ever going to be a practical proposition in the UK, but I'm sure there are other ways of silvering, doing proper silvering or spray silvering, but it does seem to work quite well for the guys out there that are doing it.
And we've got the next in-person BA meeting on March 30th at the Institute of Physics. They're just to note, you still, although it's free tickets, they're still asking to book in advance at the moment because we have to give a list and control numbers for the IOP. And then there's the in-person Winchester weekend is back on the 8th of April, and there's still tickets available for that. Again, you can access the links to book that on the BA website. I do see we have a question in from John Axtell, which is, any thoughts about the advisability or otherwise of sharing optics at start parties or outreach events?
Is this a COVID-related question?
I guess so. I actually talked to a chap. I know John asked me this question ages ago, I think, and I thought I'd reply to him, but perhaps not. And I did talk to a guy at Bristol Astronomical Society who's an optician, and he wasn't aware that there was any way that it was likely to be transmitted through tears or anything. So from that aspect, it was probably okay. But then, there's always the possibility that someone breathes on an eyepiece and they have COVID, it might be transmitted that way. So I've heard of people giving the eyepieces an antibacterial wipe or spray after each person uses it, but I don't think I would do that with my ethos or anything, any expensive eyepiece.
I think it's going to be very much up to individuals as to what they do. So at Kelling in October, we shared telescope, but people use their own eyepieces. So that worked if people had similar eyepieces. Outreach is always more dangerous because you've probably got small children who are pits of any form of disease. But I think it's just going to be up to individuals as to what they want to do and how they do it. I think wiping eyepieces with antibacterial wipes is probably not a good idea. Maybe the rubber eye cup.
I think I would recommend it, but
Well, MD Stewart makes an interesting point, which masks are good to stop eyepieces from dewing up. So if you have your breath out onto a cold eyepiece, which can then can just dew up quickly.
That's what dew heaters for eyepieces are for, Andrew.
Yes, assuming you have a power supply nearby.
Yeah, it's called a tracer battery. We work in portable in this world.
Lincoln AS, which I presume is Graham and Stanley, says that they are just using cameras and screens to display images on rather than letting people look through telescopes directly for their outreach one.
You might as well just show a Hubble image then. There's not a lot of outreach. That is
Oh dear, David's in his gym now.
Anyway, John's usually in bed by the time it gets dark.
We have not a question, but a comment on YouTube, which is from Steve Berry to say, thank you, David, for a fascinating talk and well done on dismantling and rebuilding.
The whole Richie Cretchin story, if you go on a couple of forums, you'll find it there. I've done something on Cloudy Nights, but Stargazer's Lounge particularly, I think there are a couple of links there now to some documents I've written about how to deal with the Richie Cretchin. And the originator of the techniques is Ez Reed. And I've sort of carried forward his technique and method, and I've written it up. If anybody's interested and wants to know exactly what I did, then if they get in touch with me, then I'll be pleased to share that with them through a Dropbox link.
That would be great, David. Thanks.
I've been astonishingly helping people in Sweden and the Netherlands and across the UK, and a couple of guys in the US dealing with their Richie Cretchins. So it's been a good journey. Not if you're the guy with the Richie Cretchin and you're stuck, I have to say, because it's a very difficult telescope to deal with when you got it wrong. But it is solvable.
Mm.
So if anybody wants any help, if they could get in touch with me, I'll be happy to share what I know.
Great, thanks very much, David. Hello, David, or DT, I see you're back with us. Maybe, maybe not. I've got this picture on my screen, but it seems to have frozen up now.
I think, yes, I think his connection's frozen. I'm not quite, it looks as though he might be in his observatory, so I wonder if the internet's not quite up to strength there. No, he's gone.
Yeah. Right. Anyway, if there's not any other matters, always happy to get feedback from members. Just drop me a line by email or through the website contact forms. And thanks to everyone for coming along this afternoon. Many thanks to Andy for doing all of the IT techie stuff. Thanks to Owen and David for their excellent talks. And then we'll look forward to getting together again next year in 2023 for our annual meeting, hopefully sometime in March. Bye for now, and have a good rest of the day.
Thanks all.